Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
Today, we're talking about a tiny component that is quite literally at the heart of almost everything that moves. And we're going to see how a seriously cool material is giving it a massive upgrade, pushing speed, strength, and durability to a whole new level. Let's get into it. It's a bit of a riddle, right? A space shuttle, that drill your dentist uses, an industrial grinder. Well, the common link is that they all operate in some pretty extreme conditions, pushing the absolute limits of speed and toughness. And the secret sauce that keeps them from failing? Yep, it's an advanced technology called ceramic bearings. We'll get to how they work in a minute, but first, let's look at the problem they were born to solve. You know, in any machine with parts that spin, the bearing is often the hidden weak spot. It's the thing that lets everything move smoothly, but it's also where all the friction and wear and tear really concentrate. I mean, seriously, bearings are everywhere. They are absolutely fundamental to our mechanical world. Their whole job is to reduce friction between moving parts, so things can spin freely and efficiently. Without them, our machines would just grind to a halt almost instantly. And this is where things get serious. See, when a bearing fails, it's not just a minor inconvenience. It can bring a multi-million-dollar production line to a screeching halt. The cost of that tiny bearing is nothing compared to the cost of the downtime it creates. So yeah, understanding why they fail is a really big deal. So let's look at the main culprits. According to a top manufacturer, SKF, about a third of failures are due to lubrication issues, and another third come from just plain old material fatigue. Then you've got contamination, dirt and grime getting in. All of these are classic weak points for traditional steel bearings, which, hey, kind of opens the door for a new player in the game. And that new player is ceramic. Now, we're not talking about the stuff your coffee mug is made of. This is a super advanced, high-tech material engineered to tackle the exact weaknesses we just saw in steel. Okay, so what we're mostly talking about here are hybrid bearings. It sounds complicated, but the idea is actually super simple. You take a normal bearing with its tough steel rings, but you swap out the steel balls inside for ones made of a high-performance ceramic called silicon nitride. And this one little change, well, it leads to a whole cascade of amazing performance benefits. All right, so now let's put these two materials head to head, a real showdown to see exactly where ceramic pulls ahead. And believe me, the data tells a pretty one-sided story. Check this out. This first chart shows a huge advantage, how they handle heat. As you crank up the speed, friction makes steel bearings get hotter and hotter. That wastes energy and just wears them out faster. But the ceramic bearing, it stays way, way cooler. Less friction means it can spin faster and more efficiently for a lot longer. A big reason for that lower friction is just plain old weight. Ceramic balls are about 40% lighter than steel ones. And as you can see from the solid line here, that means way less internal load from centrifugal force when things get spinning fast. The steel balls, that dashed line, are practically trying to fling themselves out of the bearing at high speed. And this table just lays out the raw numbers. It's pretty stark. Ceramic is less than half as dense as steel, but it's more than twice as hard, which gives it incredible wear resistance. And look at that corrosion resistance. Steel is low, ceramic is high. That's a massive deal in harsh environments. So what's the bottom line with all these better properties? Well, it all translates directly into a massive increase in service life. In the right applications, a hybrid ceramic bearing can last up to 5 times longer than an all-steel one. For critical equipment, that can be millions of dollars saved in maintenance and downtime. It's a total game changer. But it goes beyond just being harder and lighter. Ceramic has a few other unique properties that basically make it the only option for some really extreme jobs. These are what I like to call it superpowers. Okay, this is where it gets really interesting. Because ceramic doesn't conduct electricity, it protects things like electric motors from stray currents that can destroy a steel bearing. It's practically immune to corrosion, so it's perfect for use in marine environments. It can run with less lubrication, which is huge for working in a vacuum, like in space. And it's non-magnetic, so you can use it right next to sensitive scientific instruments. So, these aren't just quirky little advantages. They are enabling technologies. They make it possible to build faster dental drills, more reliable aerospace components, and more precise medical equipment in places where a normal steel bearing would fail in the blink of an eye. Now, as incredible as all this sounds, like any advanced technology, there are trade-offs.
it isn't a silver bullet for every single application, at least not yet.
So let's just lay it all out. The pros are obvious: longer life, higher speeds, and all those amazing special properties. But the cons are real too. The manufacturing process is tough, which means they cost more upfront. And even though it's incredibly hard, ceramic is more brittle than steel, so it's not the best choice for applications with really heavy, sudden impacts. But even with those challenges, the writing is on the wall. As manufacturing gets better and costs come down, the advantages are just getting too big to ignore. This quote from the experts really says it all. They see a future where hybrid bearings become the new standard, not the exception, tailored for exactly what each machine needs. And that brings us to a really fascinating question. We're watching a fundamental piece of our industrial world evolve right before our eyes. Is it possible that in a few decades, the steel ball bearing, a workhorse for over 100 years, could become a relic you only see in a museum? Only time will tell.
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.